I'll talk very simple thing on this, since I was asked to say on this. So next. Okay. So rivers are dynamic natural system that continuously change their courses due to erosion and deposition processes. Actually, it's okay. River erosion and bankline migration are major environmental and socio-economic issues, especially along large rivers like Brahmaputra. So, monitoring of riverbank changes is important for land management, disaster mitigation, and planning river training works, etc. Advances in remote sensing and geospatial technology enable accurate analysis of riverbank changes using satellite data. So, I'll talk in this direction only. So, different satellite data available for this purpose is open source data. I am talking first, which is free of cost, like a Sentinel-2 satellite is an Earth observation mission under the Copernicus program operated by the European Space Agency. These satellite data are mostly free. That they are Sentinel-2A and Sentinel-2B. They are lost in different date period of time. This provides multispectral optical imagery with 13 spectral bands for monitoring Earth's land surfaces. So there are different spectral bands, means a band with different, so it detects different kind of object with different color. So they have different spatial resolution, means smallest thing which it can detect is 10 meter, then 20 meter and 60 meter. So it has SWOT, means once seen how much area it covers, like that is SWOT. Very basic, some basic word generally remote sensing people use. Then level C, these are data products, top of atmosphere, reflectance, then all those things. This actually data access website, these two are website available from where you can access this type of satellite data free. Then coming to Indian satellites, these are list 3 satellite data. List 3, it means linear imaging self scanner, is a multispectral sensor used for Earth observation and resource monitoring. This is slightly less resolution of 23 meter. Then it is onboard Indian resource remote sensing satellite such as IRS-1C, IRS-1D and Resources 1 developed by Indian Space Research Organization. Due course of time, it has improved their spectral and other resolutions are increasing. It is improving day by day. Then provides multispectral imagery in 4 spectral bands. These 3: green, red, near infrared and short-wave infrared. These are bandwidth is different and it detects different kind of objects. Then spatial region 23.5 meter for visible band and NIR bands, 70 meter for SWIR bands. Different band has different spatial resolution. Then SWOT weight is 141 kilometer, means one scene it covers 141 kilometer for this SWIR band. So this has application agriculture and crop assessment, forest and vegetation monitoring, land use land cover mapping, water resource studies and environmental monitoring. So it is same only. This website, these data are available. This is list for latest, is a high resolution data. It has 3 bands like green, red, near infrared. The spatial resolution is 5.8 meter. To high details land surface observation, SWOT weight is 23 kilometer. Once resolution is high, the coverage is slightly less, so you need more data seen for cover a certain area. So these has this kind of application, same only. Large scale mapping is better, good mapping of more details of the land use land cover. Then this is used for urban planning and infrastructure mapping, agricultural crop. Actually, basically all are similar, but mapping scale improved day by day. Then disaster management and environmental monitoring. For this purpose, these satellite data are mostly being used. But इसमें कुछ image मेरा नहीं आ रहा है. Satellite images are not coming. I don't know. It's because of this software. Actually, I put lot of satellite images here. Would that it will, I don't know. None of the images are coming. It here also is not visible. It can be copied and then save as you can do save as. That will, I think it will bring it. Write that image. I am not able to. There will not be any charm of speaking. Save as. But PDF में PDF नहीं लिया था. अच्छा मेरे पास एक PDF है. I'll send it. PDF में था वो कल मैंने. पर एक इमेज आ गई. देखिए इतना सुंदर सा इमेज था, कुछ भी नहीं आ रहा इधर. This is also PPT. ये बहुत अच्छा था देखने में. आपको व्हाट्सएप में डाल दो क्या? वहाँ पे आएगा. डाल दीजिए. लेट्स सी. बट
ग्रुप में आई थिंक डालना ज़्यादा सही है. ग्रुप में क्या है, फिर लोग देख सकते हैं. ग्रुप में डाल देते हो तो जैसे आप ये देखेंगे ना, तो उसमें डायनामिक है वो, तो आप देख जाएंगे. ग्रुप पे
ना, मैं ग्रुप में मैं नहीं हूँ ना. मैं आपको नहीं, आपको पहले दे देते वो दे देंगे. ये इशू बट इट्स सॉफ्टवेयर प्रॉब्लम ओनली आई बिलीव. अरे काम कर सकते हैं हम. डाला आपने? हाँ डाला. व्हाट्सएप खुल गए. व्हाट्सएप से इसको डिस्प्ले कर सकते हैं तो आ जाएगी. ये नहीं है. ये है. So actually satellite image has a advantage that it has a synoptic view. Synoptic view means you can see from top. So it is so amazing to see how the images are, river bank is changing. This is the work I have already done. I have done for entire Brahmaputra and 98 tributaries. How river bank is shifting till 16 onward. Yes sir. Yes sir.
For how many years?
16 to 24. 2 years interval. Then there is a 4 intervals. 16, 18, 20, 22, 24. So all changes, it is the changes, red, green, yellow, then that last one, blue. These are latest from for some place, but for entire stage it is done. So this is one least 3 image showing the Brahmaputra river. I'll discuss something here later on. So satellite data, different type of satellite data. This is different resolutions. This is actually interpretation key, visual image interpretation. Actually visually how we interpret a satellite data. Here is a mapping of river bank, you say it. So here this is a river. So in different image it has different resolution, because of different resolution and it looks different. That what I wanted to show here. So this is the highest resolution. Here you will see some siltation also there. So you can judge depend on if your river is very small and stress is small, then you have to take a better resolution satellite image like LIS 4. In Google you have very good resolution also, but sometimes they have limitation of period, because in city area you will get very good latest image, but in rural area, and because we also use many time because whatever you have to buy, so that time we see if you want certain date image it may not be available. It is not available. In Guwahati city you will get latest one. Every year you will get new image, but you may not get in for any remote locations. So that time you have to buy satellite data like LIS 4. Up to LIS 3 now it is free for India also. LIS 3 has 23.5 meter resolution. Those satellite data are free now, but LIS 4 you have to buy.
What is the resolution of this LIS 4?
LIS 4 is 5.8 meter. For this type of mapping it is good enough. Actually what I did, I am showing here, you see, these are all the green color, all these tributaries. This is total coming out of 98 rivers, tributaries. So how to do visually, if you do it takes a lot of time, and if you use a manpower it will come at least 50 lakhs money for 1 year or 2 years, one changes. So visual image interpretation. So we did this some automatic method that is called NDWI. It is an index, natural difference water index. So this is not natural, it is wrong. Normalized, okay. Normalized difference water index. So what is that? Here actually there is a method which gives you the water body separating from others. Some mathematics is there, because as I told, different band we give different reflection. So with that advantage, some mathematics is there, subtraction of two band and division of two band, then this comes and it highlight the water body. It separate the water body from others. So that way we try to get the water body, these are the water body land. So that rough estimate we make all the river channels, and then it has some drawbacks still, it not very accurate, sometimes it make mistake. So after that we go to visual image interpretation, then you correct it. That is the way we have done it. So corrected it, and then we did the change analysis every 2 years interval, and then we found the changes, where erosion is there, where deposition is there. This is the example, some examples. This was 16, this is 18. So this much of erosion. This was like this. These are good land, crop land, vegetation is there. Red means here vegetation. It's a very good land, as I understand. So this has gone. This another place. This was like this, but this is reverse. This is deposited. You got new land here. So satellite image nicely it is showing within 16 to 22 this area you got fresh added to your agricultural land. but this is gone. So many areas are that in this way we can interpret it, but to do this you need to know GIS. Many GIS, so nowadays free softwares are also there. So GIS mostly we use one term called safe file, but you KMJ that is for in Google, but it is slightly not work friendly and gives some disturbances there. People can work it, but it's not like other pure GIS software. But some open source are there, they are good enough, very good, means comparatively good, better than this. This Google is giving free, how much they will give it. But the other one is software also free, but still it is another other one better to work. At least you can do digitize nicely, correctly, edit it. In KMJ file you cannot edit easily. It is tough because we are using ArcGIS, highly paid software in GIS. So then we feel we at least never do work in KMJ file or Google freely because it is not that user friendly. So that in that case we use safe files. We see, but because sometimes we don't have very good resolution satellite data, that time we go for Google. I see it, and we because in many there is a matter like scaling factor. There are so many national projects where we need to prepare land use land cover map. Say it says you prepare it 10,000 scale and you prepare it 50,000 scales. For the regional planning we need 50,000 scale also. So national figures. Nationally, when government of India declare most of the figures like what is a forest in India, then they map it in 1:50,000 scale only, not more than that. But when a village level watershed management work we do, when you plan in a village small work, then 50,000 scale map will go wrong many times. Many cases it will be wrong. Small forest area means it's 1:50,000 scale map. If you are saying a scrubland, it may not be scrubland, it may be open forest. And in that case, if you are saying open forest, it may go as a scrub forest also. And some grass, in case where problem is there, grassland, barren land, in case of Assam, multi-crop. Just I'm talking for your knowledge on a remote sensing knowledge. We need to work map multi-crop area, because there is a saying in Assam lands are lying one crop only, and 6 months is used, another 6 months is underutilization. So now government is keeping eyes open why it is like this, do something. Map first task will come to us, map where double cropping is there, where triple cropping is there. But when next cropping goes to paddy crop is okay, it is huge area, it covers large area, so we see easily with 50,000 scale also. But when it is go for potato tomato cropping is very small, so that time that 50,000 scale will land it a wrong result. So that time we go for list 4 imaging or other technique we are developing now. Government of Meghalaya now highly they become very advanced in this case application of advanced sensing, because we are there and their lack of data, and every cases when there is a mapping issue they come to us. They say satellite image, they will see everything. They feel like that, but still we are trying, because they have hilly plain and hilly area and plain area, there is a difference. Their croplands are very small, but still they need to do it. So we have done like this. So that's why I am telling. So we need scaling matter. That scale matters. So why I showed this different image, that is when you go for a small river or small section, then you should use a better resolution satellite data to understand the details. This is the example what we have done. How these are the erosion deposition. Image of 26, it is like this. Image of 18, this area. So this is a shape file. Here if you click in ArcGIS or any GIS platform, you will get the area for this portion. What is suppose if this is a cropland, it is lost. So you can say this much of cropland has lost. So if you want to assess the whatever last time we were talking now, beneficiary, benefit, what is matlab beneficiary. So now there may not become a number of people, I don't know, you can convert it also, but you will get the exact area from here. So here what we got is here, 21 districts in Assam are affected by bank erosion along the Brahmaputra river. Barpeta districts experience the most severe erosion, followed by Sonitpur, Dibrugarh and Gwalpara. This is the Barpeta has highest erosion rate. So this is the first year, this is the second year, this is the third year. After that Sonitpur also having very high river bank erosion. So that is our study only I am showing here, how different you have continuous erosion patches of Beki river, how it is progressing.
Sir, what is the revision time for this for and SWAT weight?
SWAT lease for it is at resolution of 23 meter, it will come around 50 meter.
Sir, it is collected with multiple satellites. Like Sentinel is collected. Usually I am familiar with Sentinel.
Okay.
I haven't used ACE.
Mm-mm.
Sir, and is there any provision that we get this data that if we did on any project?
Yes, definitely. Lease 3 is free now.
We will also work the same. The resolution will be 5.8 meters.
No. Lease 4 is 5.8 meter. It's 23 meter.
But Sentinel is there for
Sentinel is 10 meter, na?
10 meters.
So Sentinel is better. But Sentinel sometime you may not get the right time, that is. That's why lease 3 is free now. This is up to you. But lease 4 you have to buy. See, lease 4 these are so clear. Things are.
This for the revisit time.
रिविजिट तो मैं अभी भूल गया. ठीक है.
Sir, जैसे suppose February to Dubai, you will analyze the data of all the districts which is lying along the Brahmaputra. So can we do like this? In every district, suppose last year what is the average erosion rate? So can we work out this?
Yeah, we are doing that also. I'll show it. This is what we did. This is called EPR. Here actually this is software, free software is available. Even you have to give them vector data of 2 years. Then every small section, the change of bank line they will give. These lines are sections only, number of sections they take, and what is the deviation of bank line they shows.
The first thing is that the very first question is how you demarcate that bank line. It might be that some sand char has been counted as a bank line. Means what's the basis of demarcating a bank line? You have demarcated say 2010. You demarcated on the basis of satellite imagery that this is a bank line. But actually that's a firm bank line, or whether it's a part of char only. Because sometimes what happens, sand char get deposited nearby the bank.
Char is understood.
Sometimes some chars when they are stable, greenery is there and it could be misunderstood as a bank. So are we really sure that the bank lines we have demarcated are the actual physical banks? This backline demarcation, what is the logic behind the backline demarcation?
That is a very stable lens are there, that is the bank only, no?
Up to water line you have marked.
Water line, but water line, mostly water line we take. Water line we take. But that is not the real bank. Bank is slightly apart from the watermark. But that is again difficult for us because it will merge with the sandbar and the real stable line that disturb you. So that's why we take dry season. The water is the river channel. That is the river channel. But that also changes now. That also changes many times. That we can do. That criticality is there, but that is again if we stick arguing that, then we cannot do anything. So we have to do something. We have that. We can see. We are seeing here, but at the cost of which, where is the bank? If we ourselves cannot decide, then and different people have different views. Geologists will tell differently. Geologists will tell differently, our civil engineers will tell differently. But our motto is to solve the problem. We need to understand what it. So, but here these things are very clear. The previous image is so clear, no, how banks is moving like this. So that way you can find the places and then you can find do your preventive measures. These are different sections. How rates are going. It gives like this. This is digital shoreline analysis. Endpoint river migration rate. It is a software developed by IIT Mumbai.
The unit of this erosion you have, this is meter per year.
Yeah, meter per
year. This is
year.
the maximum extent which has went inside.
Yeah.
This average one.
Yeah.
But it should not be in this area per hectare per, means area per time.
Now here this study gives in a certain cross section. Along that cross section, how many meter the bank line is shifting. This is the way. This typical software section wise it will give, not area.
Could it not be converted into area per year?
But we have area now in different way we do.
We have area per year also in this also.
No, total area per year means 2 years we have. 2 years.
That's fine.
Apart to it is there. Because for that we make a polygon only. Channel bank line we prepare for 2020. Then again the same bank line we prepare for 24. What is the shift? And then you will get the area.
What are the inputs software required? Just the bank line blasted or any other?
Bank line only.
Just bank.
Bank line, yes. This is the way where is the shifting is high. This is the results. Like this they gives. It is a very nice software. It is free also. You can download it. It is available in the open source. So we try to find the degree of bank line shifting in the under computer only we have done. These are the results. Digital shoreline system, endpoint river. Then Siri river, both are opposite. One is this is right bank, this is left bank. Minus means deposition and plus means erosion. So here actually in this study when we found erosion hotspot, so just for our satisfaction we try to find out some river training work, what may be. These are anyway example only from Google, but this different type of example we try to do this here. This is how satellite data you can use. For this, suppose this is the real scenario. We see this river is hitting the bank. One branch is hitting the bank. Previously it was not there. But in this case, I think it is not very tough to do something. Or USR was asking, what is your justification to do this? Here, lot of justification there. The river is actually previously it was not like this. It was just flowing somewhere here only. But somehow it is. See, it is orthogonal to the bank. So definitely, if there is an embankment also. It will one day it will hit there. So here you can do revetment kind of work or river channel rechanneling. Suppose this channel is not sufficient to cover this water, I believe. That's why it is flowing the other direction. So you can increase the sizes here and maybe some.
Actually, it's a very natural phenomenon. Next per season, this char movement might be some different. Some other channel might get activated. But yes, as of now, suppose there is a situation that gets activated. So that bank might be critical. But it might be that after 2 to 3 years, this char deposition pattern changes and that bank gets deactivated.
And that is dependent by hydrological condition. And sometimes if you at all require, there are circumstances in case of Brahmapur, in case of Dibrugarh, you have to do something. You cannot.
Definitely, yes.
You have to do something, either wrong or right. You have to show something. We are doing this, or how we are doing what. In this is not hi-fi science. It's very simple. And if you want easily, suppose you say bamboo or something spar, why you cannot put a bamboo spar here? Can be. It is not at all. Yes, deposition will occur here, no? So it's very simple, and this channel will be activated. And some activation can be done, and some this dredging also. What is this? Thousands of kilometers of embankment construction, which is against our theory many times, but we are helpless. We are doing, we have to do something. Many times we are helpless because we have that only. Government has that procedure. We in the name of river mitigation, flood mitigation, we are constructing embankment. Even though we ourselves sometimes feel, okay, it has a negative impact also. But this kind of plan, I think everybody will like it. So a satellite image, if you temporal data you take is free data, nicely you see the pattern for how the river has tendency. And this is a very, I believe it is a very good example. Simple bamboo, you can put here, water will go here, deposition will occur there. So like that, so many, but in my study I have identified so many places like this, based on this satellite image, and it is available in my report.
So you publish some report about it?
Yeah, report is ready published, it is. In our record it is. So this is the example. This is 175 sites are identified for construction of river training works in the selected tributaries of 81 tributaries as different kind of. We put just, but we are not very experienced of this kind of practical knowledge we don't have. But with very minimal knowledge, with sufficient document, sufficient data,
It's actually a very good exercise.
with very sufficient data, with less practical knowledge, because I am not experienced in direction. So we put different kind of this type of what is called training or river training work. I have suggested 3-4 type of, these are porcupine, revetment. I just studied theory, Google available informations, and where what will be suitable. So I have put like this. Here I put revetment one. This is also, because why? Because this is a settlement area. This is a village. This is also village, like this. But that spar, putting spar and diverting river channel, because we have meandering channel, or what is called a braided channel. So some channel, some critical point, I think it will be very helpful if you study satellite imagery. Means that can be, suppose sir said, if you say any prepare any document DPR, I will not approve. Definitely he will not approve. क्योंकि आप पूछेगा ना व्हाट इज द लॉजिक, व्हाट इज द साइंस. अब अगर ये दिखाएगा वो जो प्रीवियस इमेज मैंने देख दिया, इफ यू शो दैट हु कैन प्रिवेंट इट, हु कैन स्टॉप इट फर्स्ट ऑफ ऑल. So these are only not much, because topic was slightly less only for me. So what I concluded here, river naturally changes their courses through the process of erosion, deposition and bankline migration. Modern remote sensing and geospatial technology help in effectively monitoring and analyze this river dynamics over the time. This analysis help erosion prone areas and vulnerable regions. We can find out. Then proper implementation of river training works and management strategies can help reduce erosion, protect land and infrastructure. So satellite imagery you can use very as a your supporting document. That is what.
The identification of this erosion is some hotspots you have identified.
Yes.
So this is basis of last 2 years, 3 or 10 years.
6 years.
6 years.
16 to 24. That is 8 years.
8 years. So this 8 years, what you have done, it might be that in 16, suppose bankline is here. Okay. Say 18, it has shifted. 19, it went. And 24, it came out. It might be like that.
No. That.
Whether it's a gradual outside.
No. We find out that gradually going out.
Okay. Then that only you have identified that it's in hotspot.
Those who are gradually going out only, that we have.
Basis of 6 years data.
Yeah, 8 years.
8 years data.
16 is the beginning, then 24 is the last. And now 26 also we are doing. We are now targeting only these areas where already identified as a hotspot.
So whatever hotspot you have identified, you are monitoring that only.
Now,
Now.
initially,
Okay. any new hotspot, it might be that some new hotspots
Ah.
have been developed.
Might be developed.
You are not going for that.
No. Actually, because as I told you, it takes time. So we'll see this first, and sometime if very critical thing come, anyway it will come to our notice.
And where is this document report you have?
Now it is not there. It is will be.
Okay. Means you haven't published on some platform.
No, it is published in our official record. It is published. We have given to FREMA also. I told you, no. It is given to FREMA. WRD also given. Now, if they use and if they ask, because we need their request, otherwise our work need to be used by somebody, because we need to invest money. Then for what? For us, the question, who is the user, whether people are using or not. So that's why I wanted to show this one. So if WRD or promoter board can use.
It's a good extent.
In fact, another project I have completed recently. You must be knowing heard about that rejuvenation of depleting wetland and then diversion of floodwater.
That NDMF funding.
Which one?
NDMA.
WRD only know that. I don't know.
Wetland provision.
That is initiated by Home Minister. No?
Yes, I know.
Mm-hmm.
Wetland conservation.
But there actually another many things I have done. I don't know. So whether somebody has check it now. Suppose flood control, only that green flood control measure you are talking. No? Now we are talking about green. But okay, green, that green concept only it is coming here. Apart from this flood water diversion, rejuvenation of the wetland, we suggested around 3,000 small check dams entire Northeast India. Small check dams of height 2 meter, and the degraded lands. Degraded lands which are called as degraded land or wasteland. So we have catchment treatment plan designed for different existing catchment treatment plan based on slope and rainfall. What is the slope? What is the rainfall? Based on ICR has a guideline. This is agriculture practice only. So they have a guideline what site of catchment treatment plan like control banding, bands, terracing, all those are there. So that areas are also identified for entire Northeast, who is contributing runoff to tributaries of Brahmaputra. So the check dams are there, around 3,000 check dams are there. So in a composite result of this catchment treatment plan, small check dam, flood water diversion with the rejuvenation of the wetland, some impact may be visible. Otherwise, what our other plan, which a major check dam is now against so major check dam, anyway major dams costly, we cannot do, it takes time. So why should we use? And this has an advantage because it is distributed. 3,000 small check dams, it can be used as a irrigation, pisciculture, and that rejuvenation of wetland we plan for tourism site also. Because rejuvenated soil, I suggested to construct an embankment in all other side apart from rather than the channel which is connected to the minor tributaries. So that excluding the channel, the other side can be made as a big embankment, and afforestation or horticulture can be planted, and then it will be converted to a tourism site. So this is the only suggestion. It's a report only, and it is gone to Home Ministry. It is there in Home Ministry, but people are only talking on that rejuvenation of the wetlands and choking all Brahmaputra river to there. Simply people say, media says like that. So that time it is will tell, but we have to see the other what we thought, and this is just to show the respect to the honorable Home Minister only. Okay, he as a political person, he is not technical person. He said Why you have lot of wetland, why you are not using it? Anyway, we are depleting or we are losing our wetland. So what is wrong with rejuvenate it? Our catchment treatment plan always prevent in siltation. The depletion is because of siltation. We can arrest the siltation in the catchment area. It is coming from the catchment only. So that is the only scientific way present available with us to arrest the silt in the source itself, rather than let it come here and dig it out and put back. So this is, thank you.
Sir, do you think it's possible to predict the flow of the river if we study like 20 years, last 20 years?
Flow of river.
Yeah.
We
For at least 1 or 2 seasons.
We are doing.
Predicting the
Anything
flow.
is doing, yes.
So sir, from that, can you suggest any probable erosion sites like suppose we are talking about Majuli sir. So can if we study the last 20 to 30 years satellite data, so is it possible that we can say that this area will be affected in the coming last 2 or 3 years?
You see, as I told, I have identified already so many points based on the erosion only. Suppose this year also the erosion is there, next year also like successive 4 means 8 years.
Okay.
For 2 years interval, 8 years I have done. Every year there is a erosion.
Entire Brahmaputra range.
Yeah, entire Brahmaputra. I had 98 tributaries I have done. Apart from Brahmaputra Bora, and 98 other tributaries we check it where continuous erosion is there last 8 years. I have checked it in 2 years interval.
2 years.
Suppose 16 it was the base, then 18 I check it whether its bank is shifted. Then 18, after 18, 20 I check it whether the same bank is going that side again or not. Again 20, 22, 20. Then only I say this section is erosion house. That way I am saying. And I have the image, corresponding satellite image, there is a proof.
Yes.
Sir, in 26, sir, it's giving the same result like the erosion size.
26 not yet done. 26 we are doing on it, but report is yet to come.
So, sir, the sites that we have suggested, sir, those erosion sites. So, if any works are done there, sir, by State Department.
No, I don't think, I don't know even if they are doing. Because I have given only. Even that rejuvenation work also going on, and but we don't know much.
And sir, while studying this satellite images, have you considered any AE works, anti-erosion works that were done earlier? Like it happens, sir, that if we are working, suppose we are constructing a spur, sir, that spurs affect some area in the downstream. Like if we are constructing a bridge, sir, this Kolia bridge, when it was constructed, it has devastating effect in Morigaon area like that, sir. Sir, have you considered that factors?
Now that we can post-mortem. Suppose some area, Morigaon area, there is a erosion. More erosion, you were saying, huh?
Yes.
So we didn't post-mortem why there is a erosion. We didn't do, but because we have, then we need the hydrological situation. We have to understand hydrology. We need to know
yes,
what is the water level. We don't know all those things. What we have noticed, what is seen, what is happened, which is visible with lot of proof, that we are saying. But remaining velocity we do not know. Water depth we do not know. It is a CWC, it may be with you. All we can compare, but for us those data are not available. We don't have that data at least.
I mean, sir, if we can, if you collaborate with suppose water resource or something, I think that will be.
And that is good. That's why we generally used to give our data. If somebody take interest from your side, then only we can. We cannot approach much.
Yes, sir.
But you can approach because you are directly linked to the villages or practical. But we are not implementing anything. Don't know. You can do study.
I think so. We are going to study the same thing that we have done. So I think we are going to do that for entire Brown.
That is already done. Why you are
Yes, sir.
saying
That's
this?
what I think, sir. So I will just stop with it.
Actually, it is given to Prema. I told WA so engineer. Before publishing, I chief engineer that time. I sit with him, with our director. It is given to him. You can ask. It's good only for what we are working. and why should I repeat? I think in case of being a some person from Assam, for remote sensing, I have 20 years experience. I have justified the work.
So we are not able to.
Yes, it is given to siblings, and that is his duty to. But many of them, many people they know because many people my contemporary engineers are there. I'm BE from HCM, so many people know. Okay, thank you.
Sir, one last thing, sir. You have suggested this GIS software, sir, the free software. Can you name some, sir? One or two at least.
QGS.
QGS.
QGS is very good.
No, but the other software from which you are calculating the meter per year, that software name is?
Digital shoreline analysis.
Digital shoreline.
So is there any free tutorials?
We did software itself. It is.
Oh.
I learned and liked it.
Thank you, sir.
Thank you. Thank you.
Digital shoreline analysis. Shoreline analysis.